Hello, ladies and gentlemen. My name is Mr. Dotson-Kelly. I am an Algebra 2 teacher at East Hartford High School. Today, I'm going to be teaching you guys how to find the greatest common factor. We are going to start by breaking down the definition and then looking at a simple example that you've seen in previous years and seeing how we can find the greatest common factor for a polynomial next. The definition of greatest common factor, I like to break it down by looking at the individual words. So the first word we see here is greatest, which I often translate to the word largest, and common, meaning the same. So we're looking for the same something that is the largest that it could be. And factor, a factor is defined as a number or quantity that multiplies to a product. So we're looking for a single item that is the largest and the same from all the terms that will then multiply to each individual term.
We are going to start off by looking at a numerical example of finding the GCF, or greatest common factor. And so it says find the GCF, which stands for greatest common factor, of 18 and 24. And the way I like to do this is I like to set this up in pairs of multiplication factors. So for 18, as an example, I'm going to end up with 3 pairs. The first pair is 1 times 18. It's as easy as just starting to move up the number line. So we start with 1, and then we say 18 is also divisible by 2, so that's 2 times 9. And then it's also divisible by 3, so we have 3 times 6. And then there's no 4. 4 does not multiply to 18. 5 does not multiply to 18. 6 does multiply to 18, but I've already incorporated 6 here, 6 times 3. So these are my 6 factors. So I'm going to write that out as a list. 1, 2, 3, 6, 9, 18. Okay, and you'll notice that they pair up from the outside in. 1 times 18, 2 times 9, and 3 times 6. Okay, I'm going to do the exact same thing for 24. 24 has 4 pairs of factors. So that's 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And again, I'm going to write out the list of these down here. 1, 2, 3, 4, 6, 8, 12, and 24. And again, you should notice that going from the outside in, they pair up to multiply to 24. So what we have here is we have all the factors of 24 and we have all the factors of 18. And the question is, which of these factors is the largest factor? The largest factor, moving from the left to the right, 18 and 24 don't match up, 12 and 9 don't match up, 8 and 9 don't match up, but they both have 6. So I'm going to highlight 6 because 6 is the GCF, the greatest common factor of these two integers. So 6 is the GCF of 18 and 24. The most mathematical way to do this is by breaking 18 and 24 down according to their prime factorization. So 18 in prime factorization form is 2 times 3 times 3. So let's think about that really quickly. 2 times 3 is 6. 6 times 3 is 18. So we can break it down that way. 24, on the other hand, is 2 times 2, which is 4. 4 times 2, which is 8. 8 times 3, which is 24. And then what we do here is we look for the numbers that they have in common. In this case, they have 1, 2 in common, and they have a 3 in common. And so pulling those out, 2 times 3, the matches, you find that that is their greatest common factor. 2 times 3 is 6. And again, we're getting the same conclusion. We are getting the same conclusion that 6 is the GCF. Okay? We're going to apply this idea of writing out the prime factorization in order to factor our polynomials. My first polynomial example is going to incorporate multiple numbers and multiple variables being added and subtracted together. So let's take a look at that. My first example is going to say factor the polynomial. And that's the prompt. And here's the problem. 22x cubed y squared plus 18x squared y cubed minus 10xy squared. And what we want to do is we want to look at the prime factorization of each of these. How do these break down? That requires us to have some previous knowledge, such as what do exponents mean for variables? And all an exponent means is repetitive multiplication. So this is telling me that the x is being multiplied 3 times and the y is being multiplied twice. So what this really is, 22x cubed y squared in prime factorization form is going to be 2 times 11. 2 times 11 gives me my 22, and x cubed is times x times x times x, and then I have 2 y's times y times y. Moving on to 18, 18x squared y cubed. How do I write down 18x squared y cubed in prime factorization form? Well, that's going to be 2 times 3 times 3. So again, 2 times 3 is 6. 6 times 3 is 18. I have 2 more x's. That's times x, and I have 3 y's times y times y times y. Last but not least, I have my negative 10xy squared. Whenever I see a negative in front, I always write negative 1 times everything else. So this negative is that negative 1. And then what is the prime factorization of 10? That is 2 times 5. So 2 times 5 is my 10. Multiply my negative 1 to get negative 10. I have 1x. If you notice that there's no exponent here, the implied exponent is a 1. It's an invisible 1, but it's there. So we have 1x and we have 2 y's. So now I'm going to come through with my yellow highlighter and find everything that all 3 of these terms have in common. They all have a 2 in common. They all have a single x in common, and they all have 2 y's in common. This is going to be their GCF, is 2 times x times y, which then simplifies to 2xy squared. If you notice, all of this came from the highlighters. So when I factor a polynomial, I need to take all those terms out and write that in front of some set of parentheses. So that 2xy squared is going to come out. 2xy squared. Now if you notice up here, I started with 1, 2, 3 terms. Inside of this set of parentheses, I'm going to end with 3 terms as well. So the first term is going to be all of this information without the yellow highlighter. Let's go ahead and highlight that a different color. I'm going to use blue. So that's 11x times x. So what do I have left over once I pulled that yellow highlighter out? I have 11x squared. That's my first term. My second term was 18x squared y cubed. So I'm going to take this 18x squared y cubed. It's going to go here again, but without the yellow highlighters. So what do I have left? I have 3 times 3, which is 9, times x times y. So 3 times 3, which is 9, so that's plus 9 times x times y. So that's 9xy. Again, I'm getting that from all of the green highlighter. And last but not least, I have one more. That's my third term. That's my negative 10xy squared. Here it is. Here's the prime factorization. I am going to ignore the yellow highlighters because they're all out here. The yellow highlighter is already accounted for. And I'm going to incorporate the last 2 things. And the last 2 things here are negative 1 times 5 is negative 5. That is how you factor a polynomial using greatest common factor.